This is the Endurance rocket ship, and she's about to discover something incredible and fundamental about the Earth. So why here? What makes Earth this special place that we all call home? One of the reasons may be due to the energy fields that our planet creates. So the first one's gravity. You're very familiar with gravity. It's important for life because it's holding our atmosphere on. If you don't have enough gravity, your atmosphere tends to escape to space, like at Mars. The second field is the magnetic field. It's this shield that's protecting our planet from the stream of particles that comes from the sun. So our rocket has discovered and finally measured number 3. It's called the Ambipolar field, and it's an agent of chaos. It counters gravity and it strips particles off into space. Whenever spacecraft have flown over the poles of the Earth, they felt this supersonic wind of particles called the polar wind, flowing out into space. There must be some invisible force lurking there responsible for this outflow. But we've never been able to measure this before because we haven't had the technology. So we built the Endurance rocket ship to go looking for this great invisible force, right? This ambipolar electrical field for the first time. So we were expecting to hopefully find the source of this polar wind, but what we weren't expecting was this other thing that it does to our skies and to the atmosphere, which is just so profound. There's only one launch site in the world far enough north to actually try and launch into this thing, and it's in the very north of this tiny island called Svalbard, just off the coast of the north of Norway, which meant a little bit of a trek to get it to the launch site. About to sail today from Longyearbyen to Ny-Ålesund, up the coast for about 14 hours. We had a couple of days of being completely whited out, and now it's calm in this beautiful country. I have a feeling this might be the day.
Solar go.
Radar.
Go.
Mission control, this is Endurance. Go flight. We are go for launch.
Yep, check 146.
I think we're about to launch a rocket.
3, 2, 1! Ignition! Knocking down! During the 15-minute suborbital flight, we successfully measured this ambipolar field for the first time. When you add up all of the strength of it over the whole flight, the whole potential drop was only about half a volt. And that's nothing, right? That's about as strong as one of those tiny little watch batteries. But that's exactly the amount that you need to explain this, polar wind escape, this outflow. Because we measured it for the first time, we can actually understand the role it plays in the atmosphere. And despite being weak, it's incredibly important. It counters gravity and it basically lifts the skies up. It's like this conveyor belt that's lifting this atmosphere up into space. So like us, you're probably left with a lot of questions, right? What does this field do? What's it for, right? How does it shape the planet? And I can't tell you yet. This field is so fundamental to understanding the way the planet works. And it's been here since the beginning, alongside gravity and magnetism. It's been lofting particles to space and, stretching up the skies since the beginning. It's probably had an impact on the evolution of the atmosphere, but I can't tell you how much yet. It may even have left a mark on the oceans, but how much I don't know. This field is a fundamental part of the way Earth works. And now we've finally measured it, we can actually start to ask some of these bigger and exciting questions.